Hello everyone, I'm here to introduce how I figure out the second part of the homework 5. First, let us see the question itself. Give fxy equals to 1 divided by a plus y22 a times y22 times x when y is more than 1 and x is from 1 divided by y to y. So first, we should draw the non-zero definition region of fxy. From the question, we can see that there are two boundaries. They are x equals to 1 divided by 1 y and x equals to y. So we draw these two. In the picture, we can find that between them there was a shadow part, and we can find that the non-zero definition region of fx1 is in this shadow part. As for the question 2, we should find a so that fxy is a valid joint density function. So as a valid joint density function, we can find that this equation. That means in this formula we can find a proper A that make these these coefficient to be valid. So from these following steps, we can find that to make this formula equals to 1, we should make sure that A equals to 2, because we can find from the final step that the second part of the formula is equals to -1, so we should make sure that the -2 divided by a is equals to -1, so the a is equals to 2. And for the second question, we should find and draw the marginal density functions fx and fy. To draw these two, we can solve this problem by integrate. That is fy equals to this question integrate by x. So to solve this formula, we can find that the fy equals to ln y divided by y22. So it's easily to draw the picture of fy itself. And for fx, we can solve it by the same way of solve fy. That is the integrate of dy. So after to integrate, we can find that when x is from 0 to 1, it is 1 divided by 2. When x is from 1 to infinity, it is 1 divided by 2 times x to 2. So we can also draw the picture of fx. And as for the last question, we should verify fx and fy are valid density function. Obviously, we can find these from the two formula and the pictures. And for fy, it's obviously that when y is from 1 to infinity, we can find the integral of itself is 1. So fy is obviously a valid probability density function. Thank you. That's all.